In section 8.5, in the second part of the section, we're going to be looking at kites and properties of kites. So first of all, definition. What makes a quadrilateral a kite? It has to have two pairs of consecutive congruent sides where the opposite sides are not congruent. So the fact that it has two pairs of consecutive congruent sides means that the congruent sides are next to each other, right? Consecutive means one after another. So this would be one pair of consecutive congruent sides, they're next to each other, and a second pair of consecutive congruent sides, one after another or next to each other sides. And notice opposite sides are not congruent in a kite. This is really the same shape of a lot of kites that you would go fly outside. Some special properties. First of all, some new properties about the diagonals of a kite. So I'm going to draw in those diagonals. Like a rhombus and a square, the diagonals are perpendicular, meaning, of course, that they meet at a right angle. They cross at right angles, so we have right triangles being formed here. Also, one of these diagonals is bisected. One of these diagonals is cut in half, and I'm sure you tell me that this one's definitely not cut in half, but this diagonal is bisected. It is split into two congruent segments here, so I'll mark those with 3 tick marks. So the diagonals are perpendicular, and one of them is cut in half. And then also we have some cool stuff happening with angles. From the original kite, one pair of the opposite angles are congruent. And you can notice that these original angles of the kite are not congruent. This is a really small acute angle. This one's much larger. But these opposite angles, they are congruent in the original kite. So I'm going to mark those with 1 arc there. Also, if you think about it, these triangles, just looking at this diagonal here, would be congruent by side, side, side now. So those angles have to be congruent by CP, CTC. With the angles, the other pair, these original angles were congruent, and the other pair is bisected by the diagonal. So this diagonal, because like I just mentioned, these triangles are congruent, we're bisecting this original angle of the kite. So these two angles are congruent here, and these two angles are congruent here. Again, you could also say that's by CP-CTC with the congruent triangles that you formed. Now the cool thing is, remember how we had these 4 original right triangles because of the diagonals? These 2 right triangles are congruent, and these 2 right triangles are congruent. So a lot of neat things happening with a kite here. Let's use all of those properties. So one thing we should be able to do is find missing angle measures if we're given, in this case, 2 angles, and actually that's all you would need anytime you have a kite. At this point I have an angle of 120 and an angle of 50. Now, I do know something about these 2 angles, otherwise I wouldn't be able to find them. Well, this is the pair of angles that are congruent in a kite. So I know that whatever's left for these 2 angles, they are the same. I will be able to find this here. And I know the angles in any quadrilateral add up to what? 360, right? Any quadrilateral is 360. So I'm going to subtract, right now we have what, 170 total? So I'm left with 190, right? 360 minus 170. So I'm left with 190 degrees. But that's for 2 angles that are congruent. So divide that by 2, and it looks like I've got 95 degrees for both of these angle measures. By the way, I should have mentioned this definitely is a kite, right? Because I have 2 congruent sides next to each other here, 2 congruent sides next to each other there. In this kite, we got a lot more going on. First of all, it is a kite. I have congruent sides here and congruent sides here. They are next to each other. Let's start with angle x, actually. Now I see my diagonals here. And if you remember, one diagonal bisects the angle. This diagonal is not cutting these angles in half. You can tell they're not congruent. But these angles are being bisected. So 42 degrees here. X is also 42 degrees. Okay, this diagonal bisects the angles. Because again, these 2 triangles are congruent, so these angles would have to be congruent. Alright, what about this y? Hey, remember, the diagonals, one of the diagonals is bisected. This diagonal, definitely not. This is length 8, this is length 3. Remember how these triangles are congruent, these right triangles? Or these triangles are congruent, these right triangles? So it makes sense that this diagonal is the one that was bisected. Therefore, y is also 7. as this part of the diagonal was here. Now the question is how I'm going to find W and Z. Another key point to remember, what angle do these diagonals meet at? They are perpendicular, they meet at a right angle, and we have these right triangles being formed. Well, hey, now that I have right triangles, and I have one leg is 7, one leg is 8, if I look at this right triangle, W is my hypotenuse, and I'm going to use good old Pythagorean theorem. So leg squared plus leg squared, here it's 7 squared, plus 8 squared equals W squared. And of course 7 squared is 49, plus 8 squared would be 64, and 49 plus 64, I'm getting 113 equals my W squared, and undo squared by taking square root. Not a perfect square, that's okay, we'll have a decimal here. W is approximately 10.63 if I go to 2 decimal places. And then lastly, what about Z? Again, I'm going to use this right triangle here. I have legs of 3 and 7. I'm going to find Z, so I'm doing 3 squared plus 7 squared equals Z squared. 3 squared being 9, plus 7 squared being 49. 49 plus 9 is 58 equals Z squared. And then to find Z, I have to take square root to undo squared. Again, 58 is not a perfect square. I'll get a decimal, and I'll just round that to 2 decimal places here. Z approximately 7.62 it would round to. And I believe we found all of our variables here. We're good to go. So using Pythagorean theorem, because of the fact that those diagonals are perpendicular in a kite. And then one more example here. In a kite, the angles measure 3x degrees, 75 degrees, 90 degrees, and 120 degrees. Find x. Which angles are congruent? Oh yeah, because remember how in a kite you do have 2 angles that are congruent, right? The angles that are in between the non-congruent sides. So this x, this 3x, would either be the same as 75 degrees, or 3x would be the same as 90, or 3x would be the same as 120. I gotta figure out which one. Well, I guess I should start out and say, what do I know for certain about the angles in this kite? Or what do I know for certain about the angles in any quadrilateral so that I could find x? Well, don't we know that the angles would have to add up to 360, right? Any quadrilateral angles add up to 360. So I'm going to do that. I'm going to take the 3x and the 75 and the 90 and the 120. And I know, no matter what, these angles need to add up to 360. It's a quadrilateral. And this will help me find x. I'm going to combine all of these here. 75 and 90 and 120 if I add those together. So it would be 3x plus 285 equals 360 degrees. Now I'm just solving for x. 360 minus 285 is 75. Hey, look at that. We know that the 3x angle is the same as 75 degrees, so which angles are congruent? 3x is the same as 75 degrees, which means then divide by 3, x equals 25. So that this angle is also 75 degrees. We have 2 75s, a 90, and a 120. I could actually sketch this kite here. I have a 90 degree angle. I'm going to start with that. Make a right angle. The 75 degree angles would be here and here. Oops. 75, so a little less than 90. A right angle will go here. $75 degrees, and 120. And that looks okay. These two would be congruent. These two would be congruent. Kind of a goofy looking kite. Maybe that's not the best sketch, but we did know to start this problem, the angles in any quadrilateral have to add up to 360. That helped me find what x was. In this case, again, 2 congruent angles in a kite. Remember, diagonals are perpendicular. One diagonal is bisected, and that creates those congruent right triangles because this diagonal is bisected, meet at a right angle, and also these angles are congruent in a kite. One pair of opposite angles, as we saw in the example we just did, and one set of angles is bisected. So looking at properties of kites today.